Find the green area. Also, what is the angle alpha? Label point B, O, C, G, D, and E. Let r and small r be the radius of the quarter circle and circle, respectively. It implies that line OB equals to line OD, which equals to r. Line OG equals to line OD minus line DE, that is, equals to r minus small r. But small r equals to the square root of 2. This follows that line OG equals to r minus the square root of 2. Also, line OE equals to line OG minus line EG equals to r minus the square root of 2 minus the square root of 2. Since line EG equals small r equals to the square root of 2, consider triangle GOC. By trigonometric identity, line CG divided by line OG equals to square root of 2 divided by r minus the square root of 2. Sine alpha equals to the square root of 2 divided by r minus the square root of 2. We call it equation 1. From triangle BOE. OE divided by OB equals to r minus 2 times the square root of 2. All divided by r, which equals to sine alpha. Since OB equals to r, it implies that sine alpha equals to r minus 2 times the square root of 2. All divided by r. We call it equation 2. Equate equation 1 and equation 2. We obtained a new equation as shown. Cross multiply. Expand bracket. The square root of 2 times r equals the square of r minus 3 times the product of r and the square root of 2 plus 4. After simplification, combine like terms and use general quadratic equation formula to find r. R equals to 4 times the square root of 2 plus or minus the square root of the square of 4 times the square root of 2 minus 4 times 4. All divided by 2 times 1. Simplify and we have that r equals to the value shown on the screen. It implies that r equals the product of 2 and the square root of 2 minus 1 or the product of 2 and the square root of 2 plus 1. Since r greater than small r, which is equals the square root of 2, r is not equals to the product of 2 and the square root of 2 minus 1. Therefore, r equals to the product of 2 and the sum of the square root of 2 and 1 in units. But line OE equals to r minus 2 times the square root of 2. Substitute value. Line OE equals to 2 after substitution and simplification of values. It implies that consider triangle BOE. Use Pythagoras theorem. The square of line BE equals the square of line OB minus the square of line OE equals the square of r minus 2, which equals to the sum of 8 and 8 times the square root of 2. Take the square root of the equation. Line BE equals to the product of 2 and the square root of the sum of 2 and the product of 2 and the square root of 2. Hence, the green area equals to the area of triangle BOE. which equals to half the product of line OE and line BE. The final result equals the product of 2 and the square root of the sum of 2 and the 2 times the square root of 2. In square units. After simplification of values. Therefore, the green area equals the product 2 and the square root of the sum of 2 and the 2 times the square root of 2. In square units. Solution to question 2. By trigonometric identity. Line OE divided by line OB equals to sine alpha. It implies that sine alpha equals 1 divided by the sum of the square root of 2 and 1. Take the sine inverse of the equation. Therefore, alpha equals the sine inverse of 1 divided by the sum of the square root of 2 and 1, which equals to 24.5 degrees in 1 decimal place.